should know about metallic oxides is that they are basic in nature. So can you guess how an acid will react with a metallic oxide? We've seen that acids and bases neutralize each other and salt and water are formed. To understand how the reaction occurs, we take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly. We continue to stir the mixture. After some time, you will notice that the color of the mixture becomes bluish-green and the copper oxide dissolves. Why does the solution turn bluish-green? It's because of the formation of copper chloride. This is a neutralization reaction in which the solid copper oxide reacts with hydrochloric acid to produce a soluble salt copper chloride and water. The general form of the reaction can be written like this. How do bases react with non-metallic oxides? Now, non-metallic oxides are acidic in nature. So the reaction of a base with a non-metallic oxide will also result in salt and water being produced. Carbon dioxide is an example of a non-metallic oxide. In fact, we have already seen this reaction in one of our previous lessons. Do you remember passing carbon dioxide through lime water or calcium hydroxide? This is the reaction we had got. Calcium hydroxide gives calcium carbonate and water when it reacts with carbon dioxide. And calcium carbonate is nothing but salt. So how can we generalize the two reactions we learnt? First, acids react with metal oxides to give salt and water. That's because metallic oxides are basic in nature. And second, bases react with non-metallic oxides to give salt and water. Because non-metallic oxides are acidic in nature. First, let's discuss what's common among all the acids. In one of our earlier videos, we'd seen that acids react with metals to give salt and hydrogen gas. If you remember, hydrogen gas and zinc chloride are formed when hydrochloric acid reacts with zinc metal. This proves something very interesting. It proves that all acids contain hydrogen. Hydrochloric acid, sulfuric acid, nitric acid are few of the examples. Now, when an acid is dissolved in water, it dissociates the hydrogen. For instance, hydrochloric acid gives hydrogen ion and chloride ion when it is dissolved in water. This dissociation of hydrogen ion in the aqueous solution is the common property of all acids. Now let me ask you an interesting question. Do you think that all compounds which contain hydrogen are acidic in nature? Let's perform an activity to find out. We set up an apparatus like this. Within a beaker, we have a rubber cork and two iron nails fixed on it. And we connect the nails to the two terminals of a battery. We also have a bulb and a switch connected in series. At this point, the loop is not really completed as rubber is a poor conductor of electricity. Now let's add dilute hydrochloric acid to this beaker. What do you notice? You will see that the bulb will start glowing, which means that the current starts flowing in the circuit. Even if we'd put sulfuric acid in place of hydrochloric acid, the bulb would have glown. Now we empty the beaker, clean it, and add glucose solution to it. Why are we trying out with glucose? It's because we want to see if all compounds with hydrogen are acidic. Does the bulb glow? No, it doesn't. Even if we add methyl alcohol to the empty beaker, the bulb wouldn't have glown. It proves that these compounds are not acidic even though they contain hydrogen. It's because they do not dissociate the hydrogen ion in the aqueous solution. What about bases? Should we try repeating the same activity with bases? A base dissociates hydroxide in water, which is responsible for the basic behavior of a compound. For instance, when sodium hydroxide is dissolved in water, it dissociates hydroxide ion and sodium ion. The anions carry electric current in the solution, and hence the bulb will glow in this case as well. A base shows its basic character because of dissociation of the hydroxide ion. We know when hydrochloric acid is added to water to make the solution, it reacts with the water molecule. How does that happen? First, the hydrochloric acid will dissociate into H+ and Cl- ions. And this happens only in an aqueous solution. And this hydrogen ion reacts with water to give us the hydronium ion. That's because hydrogen ions cannot exist alone. They only exist after combining with the water molecule. So we need to understand this well. There are two ways in which we can represent the hydrogen ions then. Either like this or like this. What about bases reacting with water? Just like acids give hydronium or H+ ions in water, bases generate hydroxide ions in water. But dry bases will never produce OH- ions. So if we have a base like potassium hydroxide and we add water to it, it will dissociate to give us K+ and OH- ions. The OH- ions generally can exist by themselves, unlike the H+ ions which form the hydronium ions. And it is this OH- ion that is responsible for the basic properties of a base. Another example here would be that of sodium hydroxide. Do you know what concentrated or dilute acids or bases mean? To know the answer, check out the next video. Let's first understand what dilute and concentrated mean generally. The most important thing about these terms is that they are relative. What do I mean by relative? Here are two beakers on the screen, one on the left and one on the right. And both have 100 milliliters of some colorless solvent. Now in the beaker on the left, I add 20 milliliters of some red solute. And on the right, I add 50 milliliters of the same red solute. In this case, we say that the solution on the right is concentrated and the one on the left is dilute. We are looking at these two relative to each other. And you can see that the concentrated solution is more red in color as compared to the dilute one. This is stronger, we can say. Let me give you another example. We take two empty beakers again, both with 100 milliliters of some solution. The first beaker has 20 milliliters of solute and 80 milliliters of solvent. And the second one has 25 milliliters of solute and 75 milliliters of solvent. Which solution is more concentrated according to you? Yes, it's the second one, because the proportion of solute is more in the second beaker. Now that you know what dilute and concentrated mean, let's move on to understanding what dilute and concentrated acids and bases are. In cases of acids, water is considered to be a solvent and the acid added to the water is the solute. So we have one beaker on the screen here with some water and we add acid to it. As the amount of acid I am adding to the beaker is increasing, the solution is getting more and more concentrated. Now let me ask you an interesting question. When I'm mixing acid and water, should we add water to the acid or should we add acid to the water? To know the answer, what we should know is that the process of dissolving an acid or a base in water is highly exothermic, which means a lot of heat is generated. Now, if we add water to the acid, the heat generated may cause the mixture to splash out, which may cause severe burns. And the glass container which contains the solution may also crack due to excessive heating. You'd probably argue that the same would happen when acid is added to the water, right? Not really, and let me explain why. When we add acid to the water, the reaction will still be exothermic, but the water is a very good absorber of heat. Yes, unlike the acid, the water absorbs the heat. And that is why adding acid to water is better than doing it the other way around. But remember, the acid must be added very slowly, drop by drop, and we should constantly stir the solution. Because if we add a lot of acid directly to water, the heat generated will be so large that even water will not be able to absorb the heat.